Welcome everyone. We are proud to present to you our new presentation about electric current and its effects. Over the course of our presentation, we will be demonstrating the symbols of electric components, the making of a simple electric circuit, and the magnetic effect of electric current with an activity. We hope that you will understand more about this complex science and appreciate its importance in our lives. So let's get started. Electric components have various symbols that are used to denote them. An electric cell is symbolized by a battery or two parallel lines with an arrow pointing away from one another. An electric bulb is symbolized by a circle or a lightning bolt. A switch in the off position is symbolized by two parallel lines crossing each other. A switch in the on position is symbolized by the same two parallel lines crossed, but with an arrow pointing at one of the lines. A battery is symbolized by a set of squares or two parallel lines with an arrow pointing toward one another. A wire is symbolized by an arrow or a line with arrows on either side. Electric current refers to the flow of electric energy from one place to another. It is facilitated by an electric cell, which contains both a positive and a negative terminal. Batteries, which are composed of two or more cells, are generally used in households for devices such as torches, transistors, toys and TV remote controls. To connect cells together, a secure cell holder is needed. Electricity plays an integral role in our lives, and it is imperative to comprehend electric current. An uncomplicated electric circuit can be formed with a cell, an electric bulb, a switch and wires. When the switch is set to the on position, it completes the electrical circuit, leading to the bulb illuminating. Conversely, when the switch is in the off position, the circuit is broken, thus not allowing the bulb to light. Knowing the basics of electrical circuitry is essential to make the most of the electrical power at our disposal. When an electric current flows through a wire, it causes the wire to heat up. This phenomenon can be demonstrated with an experiment which requires a 10 cm long nichrome wire, 2 nails, and the circuit as shown in the figure. Connect the wire between the nails, switch on the current, and after a few seconds the wire can be touched and will be observed to be hot. Once the current is switched off, the wire will not feel hot anymore, which serves as evidence of the heating effect of electric current. Electric current is an essential part of life. Numerous devices within our homes use electricity for their power source, such as electric heaters, electric room heaters, electric kettles, electric irons and hair dryers. These appliances have an element within them which is a coil of wire. When an electric current passes through the element, it gets hot and produces heat. The heat output of the element depends on its material, length and thickness. It is therefore important to use electricity responsibly in order to make the most of it. Electric current and its effects will be the focus of our discussion. An essential safety device used in electrical circuits is the electric fuse, which works by melting a wire that quickly breaks when large electric current flows through it, thus protecting buildings and their inhabitants from danger. Installing electric fuses in all electrical circuits is important for the safety of those living in buildings. When electric current flows through a wire, it behaves like a magnet. To demonstrate this, wind an electric wire a few times around a cardboard tray from a matchbox and place a small compass needle inside it. Upon switching the electricity on, the compass needle will deflect, and when the electricity is switched off, the needle will return to its original position. This demonstrates that electric current behaves like a magnet. Electric current has a significant effect on our daily life. It can be demonstrated in the construction of electromagnets. An electromagnet can be made by winding an insulated wire around an iron core and connecting the wire ends to an electric cell through a switch. When the current runs through the wire, the iron core acquires magnetic properties and attracts pins. However, when the electric current is switched off, the magnetism of the iron core dissipates. Electric bells are a common fixture in everyday life, serving as doorbells, security alarms, and more. They are composed of a coil of wire wound around a core of iron, known as an electromagnet, and an iron strip connected to a hammer that is positioned close by. When current from the contact screw flows through the coil, it creates an electromagnetic force that pulls the strip and hammer in and causes them to strike the gong attached to the bell, producing sound. After the hammer strikes the gong, the circuit is broken and the strip returns to its original position, ready to repeat the process. The versatile electric bell has become an important part of modern life, with numerous applications.